Okay, Algebra 2-4, Shapes of Graphs, Day 1. Alright, so in class, I said a couple highlighters would be handy. When we do the bottom part of analyzing the graphs, we'll use two different highlighters, or colored pencils, or pens, whatever you have. Highlighters are just easier and are the most appropriate tool, but if you have something else, you can use it. All right, so we are talking about lines of symmetry, okay? And we are going to determine whether the function has a line of symmetry or not. All right, so first we gotta kind of know what a line of symmetry is, all right? So your line of symmetry, it can only be vertical, which means a line up and down, okay? And that vertical line means you should be able to make a mirror image. All right, you should be able to take your left side, fold it over at the line of symmetry, and your left side should lay perfectly on top of your right. Let's see how this works. All right, so we have a graph of our function here. And if you go up to the maximum, the top of the curve, we can do a line of symmetry straight down. All right, we can do a line of symmetry straight down. And if we were to take this graph and fold it together, your right and your left side would lay perfectly on top of each other. They'd be mirror images of each other. And your line of symmetry is at x equals 4. Line of symmetry. Now this one over here, okay, it is a slanted line. And nowhere along the slanted line could you put a vertical line of symmetry and make the left side mirror the right. Okay, it has to be a vertical line straight up and down. And there is no vertical line straight up and down that we can draw to make the left and the right side mirror each other. So this has no line of symmetry. And we like to look at line of symmetries to see if things are balanced, like in real life. So let's check this out. Okay. Let's check out a suspension bridge cables. All right. So we have height above the water in feet of the suspension bridge cable over the distance from the north tower in feet. Okay. So the graph represents the height y in feet and that the main cables of a suspension bridge are above the water x feet from the north tower. Describe and interpret any symmetry in the graph of the function in the context of the situation. All right, so we're going to look all the way down at the bottom of our dip, the bottom of our valley. And if we want to split this in half perfectly, vertically, we could draw a line of symmetry down the middle to split our graph evenly. And we have split it at 1800. Now right down the middle. All right, so 1200 plus 2400 is 3600, and you split that in half or divided by 2, and that gives you 1800. All right, so x equals 1800. So you do have a line of symmetry. And that line of symmetry is at x equals 1800 feet. Now, what does that mean in our context of that situation? What that means is the height of the cables from 0 to 1,800 feet is the same height of the cables from 1,800 feet to 3,600 feet. And that's important because you want your bridge to be stable and perfectly symmetrical, so you don't fall off your bridge while you're driving across it. Just saying. I want my bridges symmetrical, so this is good stuff for, you know, those future engineering people. We gotta make sure those bridges stay safe. All right. So those are lines of symmetry, okay, and what they tell us and how we can use them. Now let's check out analyzing graphs. All right, let's look at some stuff we got with these graphs. Okay, looks like we got some squiggly lines. Let's give some meaning to these squiggly lines. All right, so we're going to determine the increasing and decreasing intervals of a function. All right, and we're also going to determine the extrema of the functions. Hey, that's a new vocabulary word for us, so let's define extrema. Am I pronouncing that word right? I don't know. Probably not. That's okay. I'm sure someone eventually will correct me. So, extrema. I don't know. I may pronounce it differently every time I say it. Who knows? So what that is, though, that is points that are locations of relative high or low function values. It's your maximum, those are your peaks, and your minimums, those are your valleys. All right? So we have peak and we have a valley. All right, so right at this peak here, before it turns, this is a max. And then it turns down, and it goes all the way here, and it bottoms out in this valley, and this is your minimum. All right. We got this going back and forth, so each time we peak, we have a maximum, a relative maximum. All right, each time we peak. Then each time we fall into a valley, we have a relative minimum. All right, these maximum minimums of this graph on the right are labeled. So this is actually all we're doing with this graph on the right. So our maximums, well, I'm going to highlight some stuff here in a minute. But here's what we're pointing out. Our maximums are points B, D, and F. Those are our peaks. Our minimums, our relative minimums, or our valleys, are A, C, and E. So points A, C, and E. All right. So now I said we were going to use highlighters. All right. So we're going to use our highlighters. And what we're going to do, determine increasing and decreasing intervals. Okay, so let's highlight these. All right. So I'm going to use green every time we are increasing. And we read our graphs from left to right, just like we read books here in America. Left to right. All right, so from left to right, if the line is going up, it's increasing or it's positive. If the line is going down, it's decreasing or negative. So I'm going to highlight all of my increasings green. So we are increasing left to right. We are increasing left to right. Let's check out this one. We're increasing left to right. All right. Now with my pinks, highlighter, we are going to highlight the decreasing intervals. All right. So anytime from left to right, we go down on our graphed line. All right. let's talk about this one a little more. Okay? Let's talk about when we are increasing. Okay? So when we are increasing, when this graph line is increasing. All right, it is increasing, okay, here to here, where x is less than 0. It's increasing, x is less than 0, and, because we have two of them, when x is greater than 4. We have two of them, okay? They aren't directly connected. There's a space in the middle. All right, so you have two different tails. These are tails. Okay, you have two tails. The word and is in the middle. Okay, so these were increasing. Now, let's talk about decreasing. Our pink line here. Our pink line here, we are decreasing. All right, and we are decreasing in between 2 points. See that? In between 2 points. So your x, x is, okay, your 0 is less than x, so x is greater than 0. Okay, and x is less than 4. Your x's are between your two turning points, basically. All right, so we got a hurricane on the other side. So it's going to be some winds. We aren't coming to school tomorrow. So day 2 will now happen on Monday. We are still slated to test on this unit next week because we only have one more full section after 2-4. We have 2-5, and that'll be a one-day section. And so summaries. Remember, when you do your study guide, I will be checking for the summaries of this unit, so you can start writing those out. So they'll be all done when it comes time for your binder check. All right, good luck.